Ever wondered how engineers measure tiny deformations in materials under stress? Let's talk about the strain gauge, a small device with a big job. Hello everyone, and welcome back to the channel. Today, we're diving into strain gauges, what they are, how they work, and how they're used in bending experiments to measure strain effects. A strain gauge is a sensor used to measure strain, or deformation, in a material when it's subjected to stress. It's made up of a thin wire or foil, arranged in a grid pattern, and firmly attached to the surface of a structure, like a beam, bridge, or machine part. When the structure deforms due to a load or force, the strain gauge stretches or compresses right along with it. This movement causes a small change in the gauge's electrical resistance. That change in resistance is measured using a Wheatstone bridge circuit, which converts it into a readable strain value. Strain gauges are essential in engineering, helping us test structures, monitor safety, and understand how materials behave under load. A strain gauge is constructed by forming a grid made of fine electric resistance wire or photographically etched metallic resistance foil. The bending moment is the sum of the moments of the forces to the left of the section taken about an axis through the isolated section. The stress at the surface of the bending beam can be calculated from the bending moment and the section modulus for experimental determination of the bending stresses. The bending beam is provided with two strain gauges each on the compression and tension sides. Alright, let's begin the demonstration. First, we'll apply a load to the end of the beam at full length, 385 millimeters, and observe the strain response. As the load is applied, you can see how the strain gauge detects the bending and the output voltage changes accordingly. The training system is provided with sets of weights for loading the test objects. Small set of weights 1 to 6 Newton, graduations 0.5 Newton for bending experiments. Let's start from 0.5 newtons and record the voltage variation. Now, let's reduce the beam length to 250 millimeters and apply the same load again. Notice the difference in the strain reading. Because the beam is shorter, it's stiffer, and the deformation is less. That means the strain, in the gauge's output, is also lower. This comparison highlights how beam length affects strain measurements, even under the same load conditions. When conclude our demonstration, the length of a cantilever beam is reduced under a constant applied load. The strain measured by a strain gauge decreases. This happens because a shorter beam has higher stiffness and a smaller bending moment. As a result, the beam bends less, producing lower strain. Therefore, the strain gauge shows a smaller output when the beam is shorter, even if the applied load remains the same. And that wraps up our bending beam strain gauge demonstration. If you found this useful, give it a thumbs up. And don't forget to subscribe for more engineering insights and hands-on demos. See you in the next video.